Class 8 Science, Chapter Force and Pressure. Why did the ball slow down? Will this ball start moving on its own? Force. Force is physical quantity that brings an object from rest to motion or motion to rest. What if there is no force? Object at rest will remain at rest. Object in motion will remain in motion. Man applies a force in the form of push. Bull applies a force in the form of pull. A force is a push or pull upon an object resulting from its interaction with another object. Can force be seen? No. How do you know there is force? By its effects. Effects of force. Race to motion. When the ball is kicked, the ball moves. Force, that is the kick, is used to change the state from rest to motion. Motion to rest. The ball is caught by the fielder. Force, that is the caught, is used to change the state from motion to rest. Change in speed. By stepping brakes or accelerator, speed changes. Force, that is brakes or accelerator, is used to change the speed. Change in direction. The player hits the ball to change the direction. Force, that is heat, is used to change the direction. Change in shape. Rubber string is stretched. Force, that is stretch, is used to change the shape. So the different effects of force are race to motion, motion to rest, change in speed, change in direction, and change in shape. Forces acting in same direction. Suppose there is a box and a force of 5 Newton and 3 Newton is applied in the same direction. Then the effective force is equal to addition of the forces. That will be the 5 plus 3 equal to 8 Newton. Forces acting in opposite direction. Suppose there is a box and a 5 Newton is force is given on the left side, and on the right side 3 Newton is given. So that means they are acting on opposite direction. So the effective force is equal to the subtraction of the forces. That is 2 Newton. And also the effective force is in direction of larger force. Force are of two types: contact forces, non-contact forces. Contact forces. A force which acts through a direct contact of objects is called contact force, like muscular force, frictional force. Muscular force. Can you push or lift books lying on a table without touching it? No. Can you lift a bucket of water without holding it? No. To apply a force on an object, body has to be in contact with the object. The force resulting due to the action of muscles is known as the muscular force. Frictional force. When we stop pedaling a bicycle, it gradually slows down and finally comes to a stop. A car also comes to rest once its engine is switched off. The force responsible for changing the state of motion of ball is the force of friction. Friction acts opposite to the direction of motion. Non-contact forces. A force which acts between two objects even if they are not in contact is called non-contact force. Like gravitational force, electrostatic force, magnetic force. Gravitational force. Objects get pulled towards earth due to force of gravity. Remember, gravitational force is always a force of attraction. Why does the river water start flowing downwards? Water in rivers flows downward due to the force of gravity. Electrostatic force. Do you observe any effect? No. Now rub the rod with the silk cloth. So rod is now positively charged and silk cloth is negatively charged. So bits of paper now gets attracted. The force exerted by a charged body on another charged or uncharged body is known as electrostatic force. Magnetic force. We know that North Pole attracts South Pole and South Pole attracts North Pole. That is the force of attraction. And North Pole always repels the other North Pole, and the South Pole always repels the other South Pole. So this is called the force of repulsion. So force exerted by a magnet without being in contact with it is called magnetic force. So action. Drawing a bucket from a well. So effect of if effort leads to force. Yes. Is the effort involved in an interaction between two objects? Yes. Firing a bullet from a gun. Effort leads to force? Yes. Is the effort involved an interaction between two objects? Yes. Moving a trolley. Efforts leads to force? Yes. Is the effort involved an interaction between two objects? Yes. Have you ever wondered why a camel can walk on the sand easily? Why tires in heavy vehicles are wider? Let us understand pressure. Consider the pin kept vertically with its tip touching the surface on the mold. Consider another pin lying horizontally on the surface of the board. Here, area of contact with the board is smaller for pin A, and for pin B, the area of contact with the board is larger. When same amount of perpendicular force is applied, pin at point A moves deeper than at point B. Thus, force is same, but the effect of force remains the area depends on the area on which it acts. So pressure is equal to force divided by area, that is per meter square, that is unit surface area. The force applied here is 90 degree, is perpendicular. Force is applied perpendicular to the surface of the board at the head of the pin. Thrust, the perpendicular force. Force applied on unit area is called pressure. When area of contact is less, pressure is more. When area of contact is more, pressure is less. Activity to understand relation between pressure and area. Nail with flat head on the wall. Nail with flat head on the wall. Nail with pointed end against the wall. What do you observe? That nail will not insert in the wall with flat head, but nail with pointed end can be inserted into the wall easily. Why? Flat end has more area and pointed end has less area. Area and pressure are inversely proportional. Why do school bags have broad shoulder straps? Point number one, the pressure produced by a given force depends on the area of the surface on which the force acts. Point number two, greater the surface area, less is the pressure produced. Point number three, school bags have broad shoulder straps so that the weight of the bag is distributed on a large surface and hence pressure decreases on the shoulder. Why are skyboards that are used to glide over snow long and broad? Point number one, effect of force decreases as area increases. Due to long and broad board, effect of force applied by the board on ice decreases and hence sliding on ice becomes easier. Is pressure exerted only by solids? Fluids. Substances which can flow are called fluids. Liquids, gases, Fluids exert pressure. Pressure in fluids. Solids exert pressure due to its weight. Pressure in fluids. Liquids exert pressure on base and wall of container. Gases exert pressure in all directions. Let us understand different activities for liquid pressure. Pressure in liquids. Let us take a glass tube and a deflated balloon. Now pour the water in the glass tube. Now you can see that balloon bulge sideways. Conclusion. Liquid exerts pressure sideways on the walls of container. Now let us take some water and make this side hole with a pin. Now you can see that water travels the least distance at the top of the hole, and the water travels the furthest distance at the bottom of the hole. Conclusion. As depth increases, pressure also increases. Now again pour some water in the glass tube, and there are two holes that are of different direction, but they are at the same level. Now you can see that the water travels the same distance. Conclusion. At a certain depth, pressure remains the same. Revision of pressure in liquids. Liquid exerts pressure sideways on the walls of container. As depth increases, pressure also increases. At a certain depth, the pressure remains same. The wall of a dam is made thicker at the bottom. Why is the wall of the dam thicker at the bottom? Pressure is increasing downwards. Reason: the pressure exerted by a liquid increases with depth. As depth increases, more pressure is exerted by water on wall of dam. A thicker wall is required to withstand a greater pressure at the bottom. Atmospheric pressure. The pressure that the atmosphere exerts is called atmospheric pressure. We know that the atmosphere extends to hundreds of kilometers. A man carrying 100 kg. So, how do you survive? We survive carrying such a tremendous weight on our head. This is because inside body we have fluids which exert outward pressure. So, we do not feel the atmospheric pressure. Let us conduct one more experiment to explain the effects of atmospheric pressure. Can of metal sheet with open lid and water in it. As the steam comes out, it pushes out the air that was present in the can. Let it cool with closed lid. What happens after this? can get crushed in all directions. Why this happens? Do you know the reason? Because the pressure inside the can becomes far less than that of the atmospheric pressure outside. Therefore, the can is crushed under the external pressure, that is the atmospheric pressure. This shows that the atmosphere exerts pressure on an object equally in all directions. Applications of atmospheric pressure. Rubber sucker. Why a rubber sucker sticks to the glass? The air is pushed out from the inside of the sucker, and then the atmosphere that sticks the rubber sucker to the wall. Fact from history. Otto von Guericke experiment. He invented a pump which he could use to suck out the air from a closed container. Then he joins those container and he had applied horses in both the directions, but those horses couldn't separate the containers. This is because the atmospheric pressure keeps the container, and that's why they couldn't get separated. Ink dropper. Air is pushed out, creating low pressure in the bulb. Now, due to the atmospheric pressure, the ink enters the dropper till the pressure in the bulb becomes equal to the atmospheric pressure. The spray pump. The air is pushed out, reducing the pressure inside the cylinder. As the pressure of the water inside is equal to the atmospheric pressure outside, the water doesn't fall out. Thank you. Please subscribe to my channel to get more updated videos on different subjects for different classes.